Good afternoon to everyone. So, on the third day of the student workshop on virtual labs and tools, SWVLT 2021, organized by the Department of EC on behalf of HIT Haldia, a warm welcome to all respected faculty members, technical staff, and my dear students. The honorable speaker for today is Mr. Bhaskar Roy. He is eminent faculty from the Department of AIE from Asansol Engineering College, and he will be delivering a enlightening talk on the virtual lab platform using PSPICE and what are the various applications of PSPICE in the field of electronic circuit analysis and simulation. A short overview will be there for the next 1 hour. The YouTube live streaming has already the YouTube live streaming link has already been sent to the students and all. I request all the students to listen to the lecture and please post your queries at the end of the chat, and those will be addressed after the talk is over. So once again, I take this opportunity to welcome Mr. Bhaskar Roy on behalf of the Department of EC, and I welcome you, sir.
Thank you, sir. Thank you. Thank you.
Thank you, sir. You are audible, sir. No problem. So I am stopping my screen share. Okay. So you can share the screen now.
Is it visible?
Yes, sir. Yes, sir. It is fully visible.
Okay. A very good morning to all present here, all the faculty members and the students. Hope you all well. Today, I will give my presentation about the PSPICE fundamentals using the virtual lab. Now, the first is the introduction part. So, in the introduction part, we should know what is PSPICE. Actually, PSPICE is the simulation program for integrated circuit emphasis. This is the full form of SPICE. This is a general purpose analog circuit simulator used to verify different circuit designs by creating electronic schematics and to predict and test the circuit behavior. So instead of using the hardware breadboard or any other hardware components, we can use that part in this particular software. So this is basically a software based breadboard, you can say, where you can design various electronic circuits. You can test over there. PSPICE is a computer software package developed for simulating the electrical and electronics circuits. And PSPICE was developed at University of California at Berkeley for mainframe computers. And the P stands for, actually, this is the PC version. PSPICE means the PC version. That means we can use this version for our personal computer. Another version is there, that is the HSPICE, that is used in the large computers, workstations like that. And this PSPICE has analog and digital libraries of standard components such as NAND, NOR, flip-flops, op-amps. So different analog and digital components libraries will be included in this particular PSPICE software, which makes it a useful tool for a wide range of analog and digital applications. Now, coming to the types of analysis, Now, there are various types of analysis we can perform with the PSPICE, like the DC analysis, where we can obtain the characteristics, diode characteristics, or Ohm's law verification. Then AC analysis, that is the frequency domain analysis. Then transient analysis, that is the time domain analysis. Then Fourier analysis, noise analysis. So there are different kinds of analysis are there, which can be performed with this PSPICE simulator. Now, what are the basic circuit components? The basic circuit components that this particular software includes, like voltage, the common components like voltage and current sources, whether it is dependent or independent. Then resistor, capacitor, inductor, those are passive elements, mutual inductance. Uh, Transmission lines, op amps, very important for our lab experiments, operational amplifiers. Then switches, diodes, bipolar transistors, MOS transistors, JFET, MESFET, digital gates, 555 timer, and many others essential components included in this particular software. So that's why the range of this software is very high. We can implement any our electronic oriented circuits with this particular software. We can design and simulate. Now, the PSPICE modes. This particular SPICE can be different types of software available for this particular SPICE model. First of all, one type of software is this under the SPICE, that is the Capture CIS. Capture CIS is the software developed by the Cadence, and this is the schematic representation actually. So schematic representation, ORCAD student version 9.1. So this software is readily available. This is open source software, so the students can access from the internet. I have given the link also in this PPT, where from where the students can download this particular software very easily, and the steps of the installation is very simple. Common steps are there. So this is one type of SPICE software, that is the Capture CIS schematic ORCAD student version 9.1, and this is the symbol, the logo of this Capture CIS Lite simulator. Then another type of very useful nowadays, that is the LT SPICE. Okay, so this is the linear technology SPICE model, LT SPICE. This is very useful. This is also the schematic representation. Schematic representation is there. And another type is this, that is the PSPICE schematic. That is our general PSPICE, whatever we are using in the lab. That is the PSPICE schematic. And this PSPICE, another form of this PSPICE is the PSPICE text. So you can use both, whether you can use the PSPICE schematic as well as you can use PSPICE text. So both versions are available. So this is the logo of the PSPICE schematics. So these are the different SPICE modes. So any kind of software you can use for your design to build any to design any circuit or to test any circuit. You can use any of these 3 or 4 options. But for the students, they can prefer this capture, or they can prefer this LT SPICE or the PSPICE schematic. But my personal opinion is that this PSPICE text is not very suitable for the students, because you have to write some codes over there. So rather than writing the codes, you can just use the schematic representation. That will be much more easier for the students. Now these are the acquiring PSPICE, how you can acquire PSPICE. So I have given these links to you. Actually, after this presentation, I will send this presentation to Tilok sir, and Tilok sir will delivered to you. And in that particular in this particular slide, I have given all those links to download links for those software. So this, the first link is for the capture PSPICE or capture light PSPICE link. So you just click that particular link, and one exe file you can download. And after clicking the exe file, you can install this particular software in your laptop or PC. So installation process is very, very easy. Then another link is there. This is the PSPICE 9.1 student version, and this is the LT Spice link. So all these links are available. You can access all these links, and as per your requirement, as per your choice, you can download any of these software. Now, coming to the capture PSPICE interface. First of all, these are the these are the different steps how you can draw some circuit in the capture PSPICE interface simulator. So first of all, draw an electronic or electrical circuit on the computer using capture, simulate it with the PSPICE, using PSPICE models for your device, analysis its behavior with probe, which can produce a range of plots. So historically this was a separate application, but it is now is integrated with the PSPICE. Previously it was separated, but now it is integrated with the PSPICE model. PSPICE software. So this is basically the toolbar, how it looks like if you download the software and opens the software. Then this is the first screen, and in that particular screen you can find these are the options. These are the different options, like your MS Word. File options are there, editing options are there. So like that, you have several options here. So this particular blue color option is to run the program. Okay. Then these are the zoom in, zoom out options. These are the probe options. These are the component options, the different components you can choose. This is the toolbar for schematic window. So this particular symbol, which is written place place part. So this, but if you click this particular symbol, then you can access all the components under this capture toolbar. Okay. Now see, this is the parts. Parts is the basic building block which may represent one or more physical elements, functions, and simulate model. So if you click here, then this kind of window will come. Okay. If you click here, this parts symbol, then this kind of window will appear. And you can choose from this window, as per your requirement, any component you can choose. Okay. But remember, whatever component you want to choose, that should be included in the library. Okay. So one option is there. See the third option here. This is the add library option. So you can add different library functions by clicking this as per your requirement. Okay. So for example, I want some voltage sources, some specific voltage sources. So you have, I have to include those files in this particular library. So in this way, you can include. Say for example, this is written R, small r. So R means resistance. So if you search, write small r here in this particular box, then this kind of schematic will appear. See, this is the resistance. Okay, this is the resistance of the value of 1 kilo ohm. So you can just double click here, and this particular resistance will go to your editor. Okay. Now, how to getting started with this software? So you have to go to the file, then you have to click the new option, then you have to click the project. Okay, so whenever you click the project, then this kind of box will appear. This dialog box will appear. Okay, see here, this is the name. So you can write any name as per your choice. Say for example, you want to simulate a half wave or full wave rectifier. So you can write half wave rectifier or full wave rectifier here as a file name. Then you must click this particular option, analog or mixed AD. So analog or mixed AD, you have to choose. Okay, then you click the OK button. Now after clicking the OK button, the next comes this window. So it has two options. You just choose the lower option, that is the create a blank project. Create a blank project, because you are new to this software, so you have to create a blank project. So just click here, select this create a blank project. Make sure select create a blank project, then click OK. Now after clicking OK, you will get this kind of editor. Okay, so this is the typical schematic window. Actually, it is looks like this kind of window will appear in your screen. Okay, so we have several options here, as I told earlier, and we have some component options. Now again, you can choose in the same way. You can choose the placing the components. For placing the components, you just click that component part button, and say for example you are choosing R, that means resistance. So then click OK. Then this particular resistance will appear in your uh, previous editor box, that means in your uh, schematic screen. Okay, like this. See, this is the example, one example I have chosen for you, that is the high pass filter, RC filter. So first of all, you have to place those components from the different components from that component part button, clicking the component part button. So place the component source and ground. Obviously you need some sources, you need some ground to build up the whole circuit, otherwise it cannot work. You probably know that. So first of all, you choose the different passive components like resistance. Okay, see, resistance, 1 kilo ohm resistance is chosen. Then some capacitor is chosen here, because this is the RC filter. Then we have to choose some AC source. For this particular experiment, we have to choose some AC source from the same way. From this particular see here, if you if you write source, then some source options of sources will appear, and you have to choose one source from there. So if you want DC source, then you have to choose the DC source. If you want to choose the AC source, then you have to choose the AC source, like that. So for this I have chosen the AC source here. So 1 volt AC source is there, and obviously this is the ground. This is the ground. Okay, this is the ground I have chosen. Now you have to connect all these components with some wires. Okay, so wire option is there in this particular panel. Wire option is there. So just clicking the wire option, you just connect all these components by clicking this. Okay, and also you can choose the probe. Okay, to find out what should be the voltage at this particular node, or what should be the voltage at this particular point. You can use these type of probes. Okay, by choosing from the upper upper panel. So this is the complete circuit. Now creating new simulation profile. To now go to PSPICE option, the upper file menu, the one option is there, that is the PSPICE, and under PSPICE you can choose the new simulation profile. So as you choose the new simulation profile, then this type of box will appear. So you have just write the name of the experiment, say for example your RC circuit, and then create, then click the create. and after creating, you have to mention the analysis type, what type of analysis you need. Okay, whether it is a DC analysis, whether it is a AC analysis, that kind of analysis you have to select. Okay, so for that we can choose any of the analysis option in the upper menu bar, and by clicking the analysis options, this type of dialog box will appear. And if you choose see, this is the analysis button. If you click this analysis button here, and as we are providing AC source, so obviously we have to choose AC sweep noise. This option we have to choose from the several options. There are other several options like DC sweep, all the options are there, but out of that, as per our requirement, I choose the AC sweep. Okay, and this is the general settings you have to choose. Then this is the decade logarithmic, because the output of the filter is not a linear one. Actually, this is the something exponential type logarithmic. So we can choose this logarithmic button here and decade, and then start frequency. So ultimately our aim is to plot the frequency versus gain plot for the filter circuit. So in the x-axis we are providing the frequency, and at the y-axis we are providing the gain. So for that we select the start frequency and the end frequency, um, uh, values. So for example, we choose one as a start frequency, and 100K as a end frequency, and the intermediate point, that means the increment point, is 10. Okay, so after this you just apply and then okay. So after that you want to run, actually run the program. Okay, so one run button is there. I have already said one run button is there, blue color run button is there. So you just click that run button, go to PSPICE and then run button, and another waveform window will appear. This kind of window will appear. Okay, so the upper portion, see, this is the black portion. This black portion consists of our desired waveform, our required waveform. Okay, this is actually the required waveform, and at this particular window, these are the some comments given after my after I run the program, whether is there any error is there or not, whether any line has bad comments or not. So that kind of error or message will be provided by the PSPICE in that particular window. So if no error is there and we are getting some curve here, then we can see the result. So if you see, this is actually the output waveform of the high pass filter. So here this is the frequency and this is the gain. So frequency versus gain plot is there for filter circuit. So as you know, in the from the theory of the filter circuit, high pass filter, so all the high frequency components will be passed and all the low frequency component will be cut off. So here up to almost 1 kilohertz, all the frequencies, sorry, 1 point something kilohertz, all the frequency will be cut off, and above those frequency, all the frequency will be passed on. So this is the nature of the high pass filter. Now there are as I said, there are different types of analysis. In the previous case we are going for only for the AC analysis, but if you want DC analysis, then you want to choose the DC analysis, DC sweep here. If you want transient analysis, time domain analysis, then you have to choose this time domain transient analysis from that particular options, like that. Now next I would like to show the LT spice, another spice environment another spice simulator, which is called the LT spice, linear technology spice. This is also a schematic representation of the circuit simulation, and you can download this particular LT spice from this particular link. Now, here also, if you see, this is the summary of the schematic editor toolbar of the LT Spice. Similar, more or less similar to that we saw in the previous capture light simulator, something similar. So, like that, if you see, these are the delete options, these are the duplicate options, then move options are there, and this particular is the circuit, place the circuit element. See, place the circuit element, this particular switch, this particular button. If you click this particular button, then you can avail, you can access all those components, whether it is resistance, whether it is a diode, whether it is any other components, you can access by clicking this particular place circuit elements. So if you particularly place the diode, then you can use this particular symbol, diode symbol. Then inductor is there, place inductor, then place capacitor, then place resistance. So separately it is given. Okay. There are several options. Then label node, you can assign the label node. Then place the ground, you can assign the ground terminal, ground connection. Okay, so all these things are there. But remember, this is very, very important. These are the some common levels to specify the units of the circuit elements attributes. Like K, we can represent K as a kilo ohm. Okay, so 10 to the power 3 ohm. That is okay. But mega ohm, 10 to the power 6. Okay, mega ohm. So use meg to specify 10 to the power 6, not m. Usually we supposed to write m, capital M for mega ohm. But in this case, if you use m, capital M, then it would take milli 10 to the power minus 3, because capital M represents here the milli, not meg. So remember these things. Meg means mega ohm, 10 to the power 6. Similarly, if you enter 1 for 1 farad, not 1F, because F is denoted by some femto dimensions. So 10 to the minus 15. So F represents the femto. So whenever you write 1, that means 1 farad. So like that, you just remember some of these things. Now, this is some examples using the LT Spice. So this type of circuit you can also implement and simulate with the LT Spice. So this is a simple resistive network with some voltage and current source connected, and these are the voltage source VS with 10 volt, and this is the current source with 5 milliampere. And we are connecting the resistance here, Rx 1K, then Ry 2K, Rz 3K, and then again another resistance is there, that is R1 is 500K. And we are connecting the ground here. Okay, we are connecting the ground connection here. And these are the node voltages. Actually, PSPICE deals with the nodal analysis, node voltages. Okay, so these 10 volt, 10 volt, 12 volt, 14.5, these are the node voltages at this particular different particular node. Okay, so V1, V2, these particular nodes represent these voltages. And this is the net list. Actually, that means you just draw the you just design the circuit, but you can also see what is the coding behind this particular circuit. Okay, so this is the net list. So you can choose one option to get this particular net list. And this particular netlist shows that V1 means that particular this one. So this is the 10 volt. Okay, this is 10 volt. Then V2 is this 12 volt. V3 is this node 14.5 volt. Okay, then currents is, that means the source current, R1, current through the R1. So these are the values of different currents, branches of different currents. So you can just see those values in this particular netlist. Similarly, we can the same circuit, but we just implement one V out here. We can implement one label. This is called the label net. Okay, so V out means you are just want to take the output from this particular node. So this is the V out. Okay, so by the option label net, you can actually implement or connect this particular V out at this particular point. Okay, so as you connect V out, then see what is the change from the previous. This V now is V out 14.5. So actually previously this node is V3. Now instead of V3, it is now V out. So V out represents 14.5 volt. Initially it was represented by V3 14.5. So this change will appear. Now the next one is the schematic PSPICE interface. So this is the normal general PSPICE model, not the LT spice. So in this particular PSPICE, we are showing some examples. So if we want to draw this particular circuit, this is a simple circuit. We are just providing a voltage source here, then connecting some resistance in series with this voltage source, then connecting the ground, and we are connecting some probe. This is the current probe to determine the what is the current, what should be the current at this particular point. Okay, so you can choose probe from here. These are the probes. These are the probes options. So we can choose, just click the probe option and place here. Now one very important thing is here, that is that this voltage source, we can vary this voltage source. Actually by this circuit we can verify the Ohm's law, V equal to IR. You know Ohm's law, V equal to IR. So as you increase the voltage, as the resistance is constant here 1K, so gradually current will increase, linear function. Okay, so you have to put the voltage source in a, not in a constant mode, but in a variable mode, sweep mode. Okay, and obviously it is a DC voltage, so you can use the DC sweep. So you just click the from the analysis button is there in the above menu. One button is there, that is the analysis button. Okay, so if you click at this particular on this particular voltage, then also you get this particular dialog box. So this is the analysis setup. What kind of analysis you want to implement? Is this AC analysis? Is this DC analysis? Is this Monte Carlo? Is this bias point analysis? So as per your choice, as per your requirement, you can choose any of these analysis setup. Okay, so for this, as this is the DC voltage, and we are going to vary the DC volt, say for example from 0 to 0 to 10 volt. Okay, we are going to vary from 0 to 10 volt. So we just click this DC sweep. We just check box is there. We just check this DC sweep and click on this DC sweep button. As we click on this DC sweep button, then another box will appear. This box will appear. Okay, this box will appear. So this is the DC sweep box under this DC sweep switch. So it signifies the sweep variation type. So how you will vary? You will, whether you will vary in temperature, whether you will vary in current, whether you will vary in some other parameter, but no, we will only vary in accordance with the voltage source. So we just choose the voltage source here, because this is the voltage source, and we just vary the voltage. Okay, so voltage source, we can choose this button. Then what type of variation, whether it is a linear or non-linear? Obviously it is a linear function, so we are going to choose this, sorry, we are going to choose this linear button here. And after choosing these two, then you have to mention the name. Okay, what should be the name? The name of this particular source. So see, the name of this particular source I have already given V in. So you just copy this V in here. No other nomenclature is permitted. Okay, if you say, if you write V1 or any other, then it will not work. So just copy this V in here. So name is V in. Then you have to start. What should be the start value? From 0. Obviously from 0 you have to vary up to 10 volt. So the start value, you just put 0 volt, and the end value, you just put 10 volt. Then you have to increment. You have to increment. How much incremental value will be there in between? So is it 0.5? Is it 1 volt? Is it 2 volt? So I have chosen 2 volt as an incremental value. Okay. Then click the OK button. After clicking the OK button, you just simulate. You just simulate or run the from the particular simulation button, and you will find this kind of waveform will appear. Another new window will appear. This is the waveform window. Okay. So now if you see, this is the voltage axis that we can vary from 0 to 10 volt, and this is the uh, current axis from milliampere range. So the curve, if you see the curve is gradually increasing. So as the voltage is increasing gradually, then the current will increase gradually. So this is nothing but the Ohm's law, because the resistance is constant. So in this way, you can implement this kind of circuit by the PSPICE. Then again, the second type of circuit is there, that is uh, almost same circuit. So here also we have a DC voltage. This is the source resistance, this is the R2 resistance, this is the R1 resistance, 1 kilo ohm, 3 kilo ohm, 5 kilo ohm. Then one current source is there. So after then one comment is very important, that is the attribute comment. If you see this, button, see this button, this box, white color box button, this button is called the attribute button. Attribute means if you click the attribute button, then you can change the values of these parameters. Okay, so use attribute to change the value. Then after completing the circuit, you can go to the edit menu. Where is the edit menu? This is the edit menu. See, this is the edit menu, like your MS Word. And from the edit menu, just copy to clipboard option is there. Copy to clipboard. So if you choose that option, then you can copy this particular schematic from this particular schematic window to your Word file. Okay, so you just copy, go to the edit and then copy to clipboard, and then paste your circuit to your file, MS Word file. And from the analysis, you can examine the net list also. So analysis, one analysis button is there. See, this is the analysis button here. After operations, this is the analysis button. So if you click this particular button to examine the net list, so one option is there under this analysis button, that examine net list. So you have to click that examine net list button, and then what will happen, that net list will open. Net list means a particular code behind this particular schematic design. Okay, so that you can also copy to your MS Word file. Similarly, by the PSPICE, we can use nonlinear circuit also. So this is the nonlinear, basically diode input characteristics. So this is a simple circuit I have chosen. So this is the diode D1. This is node 1, node 2, and this is we are giving the voltage 1 volt DC, which is nomenclatured by V1. This is the ground potential, and another load resistance is there, that is the R1, which is 1 kilo ohm. Now after the simulation, what should be our output? Obviously the output we are getting is this type of output. Okay, then again you have to vary, vary this particular voltage. This you have to sweep this particular voltage from 0 volt to say 1 volt or 0 volt to in this case we are going to vary from 0 to 1 volt. Okay, so see, after 0.6 volt, this curve will gradually increasing. So you know that that is the cut-in voltage of the diode. Okay, so for silicon it is 0.7. So in this way you can implement the diode characteristics also by this PSPICE circuit simulator. Then the final one is the PSPICE interface. This is the command, basically the command editor. So this is the general structure of the syntax command. So you can implement, you can implement this particular format for your programming text PSPICE programming part. And these are the output and input text file format. Now if you see this example, this is the circuit. Okay, this is the circuit. This is voltage source, this is current source, these are the some resistance in between, 1 ohm, 3 ohm, 5 ohm, 2 ohm, 4 ohm, and this is the ground connection. Okay, now the problem statement is that in this circuit, find the current through the R2. So where is R2? R2 is this one. So you have to find out the current flowing through this R2 and voltage across this voltage across this resistance R2. And also you have to find the current through the R5. This is the R5 resistance. You have to you have to find out the value of which is going through this current going through this resistance R5, and also voltage across this R5. So for that, this is the code, and this particular code you have to write in some editor of the PSPICE text editor. Okay, because in the previous case you just implement or schematic, you can draw the design the circuit, but here you just write down the codes. Okay, and after simulating you will get results. So if you see this code, this is the DC source, so DC circuit analysis. So vs is the source. So vs 10, why 1? Because this node is 1, this node is 1, and this is ground, so this node is 0. So 10 DC 10 volt. Okay, because we are giving 10 volt supply. Similarly, is the source, current source. So again it is connected between 4 and 0. So 0 4 DC 1 ampere. So 1 ampere current is there. Similarly, R1 is this between 1 and 2. So 1 and 2, how much the value? The value is 1 ohm. So 1 is written. Similarly, R2 202, R3 233, R4 304, R5 345, and you have to choose these commands. These are the inherent commands. .dc, because this is the DC analysis. Print, you have to for the print the value of the current across this R5 and R2. So print DC IR2 V2.0 IR5 V3 comma 4 as per your problem statement. Okay, then dot end, then output. So you will show this output here. These are the various commands of PSPICE, very common commands. Now these are the some references. You can use these references. These are very, very helpful references. Now I am now going to demonstrate some actual practical, just one or two examples I have taken. One second. Tilak sir, is the screen is visible? Hello.
Yes, sir. Screen is visible.
The LT Spice screen, white color screen is visible.
I am right now.
No, sir. Only your
No. It is showing only PSPICE Fundamentals.
Okay,
PPT
okay.
screen. So you just exit, stop sharing your screen, and then select the particular window.
Okay.
Firstly, you stop share the screen.
Zoom এ যাব না?
হ্যাঁ স্যার।
এখানে হচ্ছে
On the top, you can find the stop share.
new share is there.
It's a view share, and beside that, stop share.
Pause share.
Okay, click
Okay.
on new share and then select the particular window.
Okay. Yeah. Now?
Yes,
Yes, sir. Yes.
Okay.
One circuit is being seen.
Okay. Now this is actually the LT Spice editor. Okay. This is actually the LT Spice editor. Now, okay. Now, say for example, this is the resistance. This is the resistance. You just click this particular resistance and drag in this particular editor like this. If you right click, then automatically it will be deselected. Okay. Say for example, I choose another resistance here. And how to rotate this resistance? Just see, this is the option, rotate. Just click, then it will rotate like this. Then you can put here. Then this option, this is the zoom full extent. So if you click, it will actually fit into the window. Then again you can zoom out or zoom in. Okay. Then comes this is the cut option. See, this is the cut. If you click here and then you just click on any of the component, it just removed. This is the cut option. And this is the wear option. This is the wear. Okay. Say for example, I want to take this capacitor. So this capacitor is there. Then I want to join or connect by this wear. So click the wear and just click here once, then again, and just click here. See, the connection has been made. Okay. Similarly, I want to click this particular point here, then again click here, then again here, then again. So in this way, you just use this wire to connect your components or connect your sources or ground, whatever. This is the ground. You just click, this is the ground connection. Okay. This is the inductor. This is the diode. This is the component. See, here, if you search, say, volt, V, see, voltage is been selected. So if you, so this type of voltage source you want to take. So you just click then paste. Say, for example, you want to take some say diode is there, I think. Smith trigger, okay. CHF, Smith trigger. Yeah, this is the Smith trigger. See, Smith trigger. So Smith trigger block also you can take. So in this way, by this component, you can choose any of these component as per your requirement. This is the undo, and this is the move. So if you click here, then you just move as per your requirement. Move any component. And this is the drag. So if you, yeah, you can adjust by this drag button. Okay. So I just cut all these extra added elements. Okay. So this is the actually the circuit I have made for you. To save the time, I have already make this circuit. Now, first of all, you have to go to the simulate. This is the simulate. Okay, simulate. Then see edit simulation CMD. One option is there, edit simulation CMD. So you click here. Then one window comes. So as we are using DC voltage source, so this is the DC operating point analysis. So there are several analyses: transient analysis, AC analysis, DC sweep, noise, DC transfer, DC operating point. So as per your requirement, as per your choice, you can choose this analysis. Okay. So for this particular circuit, I have to choose DC opt. So you just click here and then OK. So as you click the OK button, then .op, this command, see, .op command is there in this particular schematic. Okay. Then go to the view. This is the view, and this is the SPICE net list. This option, SPICE net list. So if you click this SPICE net list, then see some net list commands is window comes. Okay. R1. See, this is R1. What is R1? R1 is this. This is the R1, the middle resistance. So R1 is connected in between. R1 is connected in between 0 and this particular point. That means the V out point. Okay. So that's why R1 0 V out, how much? It is 1K. So 1K is written. Similarly, VS. VS is the source voltage. This one. Okay. So source voltage is connected in between this V out. Sorry, this V out 0 is the ground. This is the ground. And how much the voltage? The voltage is 1 volt. So VS is connected between this V out and this 0 ground with a value of 1 volt. Similarly, R2 is between V out and the ground potential with a 2 kilo ohm resistance. And then .op is that particular command that I have already chosen for the DC operating point command. So like that you can choose. Then you can right click over any component. Say I have to right click to on this particular source. Okay. So see, 1 volt is written here. So you can change. You can change, say 2 volt. You can change 2 volt. So just click OK. Say, see, this is changed to 2 volt. Okay, then you can choose the level. This is VS. You can also choose the nomenclature. Say, for example, I want to give V in. So you just click, and then at this particular space, you can given V in can be given. So V in. Okay. So in this way, you can construct any circuit by this particular LT spice. Okay. Okay. Another software is there, that is the PSPICE. Okay. So this is the PSPICE editor. This is the Tilak sir, PSPICE editor is shown or not?
I can
No,
see
sir.
the
You just go to new share.
Okay,
Then
okay.
you can.
PSPICE.
Then you select the window. Just
I can see the diagram, that the
just like the
circuit
before.
diagram, but not the PSPICE editor.
Now?
Yes, 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 yes.
Okay.
Now it is visible.
Okay. Now see, this is the PSPICE editor. So I have already made a circuit, a diode circuit. This is the diode D1. And how can you choose the component? By this get new part. This option is there, get new part. So if you click here, then see, say for example, you just write diode. So different types of diode list will appear. So I just choose this 1N4002 and place, click place. So as I place, then automatically this particular diode is dragged in this particular editor. Okay. Similarly, we can choose the voltage source. See the VDC place. This is the voltage source. So similarly, we can choose the ground. Similarly, we can choose the resistance. So in this way, we can choose all those components, all those components which is required for this particular circuit by this particular get new part button. Then how to connect? The connection has been made by this draw wire. Okay. Say, for example, I want to connect this to this. So like this, you can select this wire option, draw wire option, and connect any of your component. Okay. So I just delete because this is not the right one. Okay. Now this is also zoom in, zoom out as previous. And this box is the modular box. So you can choose this type of box for your design also. Block diagram. Okay. Now this is the analysis. This is the simulate. Okay. This is the examine netlist. See, whatever I have drawn at particular this circuit, this is the netlist. This is the coding part. Okay. Now click here, setup analysis. This button, see, this is very, very important. Setup analysis. So if you click setup analysis, then this box will appear. So what type of simulation, what type of analysis we have to choose? Obviously, this is DC. So again, we have to sweep the DC voltage from 0 volt to say 1 volt. So we choose this button, DC sweep, and then click on this DC sweep, and then the voltage, choose the voltage source, linear V1, because V1 is this is the V1. So we have to write V1 here. and the range, start range is 0 volt and end range is 1 volt, and incremental value suppose 0.1. So then click OK, then close. Okay. Then comes this button, simulate. So as we simulate, then this particular window will come. So this is the final simulation, simulated waveform for this particular circuit. So as you know, the diode characteristics look like this, voltage versus current, VI characteristics look like this. So 0 to 1 volt is the range, and this is the current axis. And after say 0.5 something, the curve is gradually increasing very fast. And this is the window whether any error is there or not, that will be furnished here. Okay, so in this way you can use your PSPICE tool in a different way. Share. Okay, but I think I have completed from my side. If you have any question, you can ask. Tilak sir,
Yes, sir.
time to
Thanks.
হয়ে গেছে, ওই জন্য আমি করে দিলাম।
Okay, sir. Okay, sir. Thank you, sir. Thanks a lot for sharing and giving us your valuable time. Though the time is short and we are running out of means, some limitation is there for the time, but in spite of this, you have given an enlightening talk on the topic on PSPICE and a brief overview about the fundamentals, so that the students can grab the essence of the knowledge and how it works on the electronic circuit emulation, means simulation, analysis and tools. Just sir, one or two queries I have. Can I ask you? Means
Yes, yes.
from the student side also they are posted. So just like means, is there any limitation like about the number of components, or means suppose the circuit becomes too much complex with more number of means components, connectors and all. So under that condition, is SpeedSpice means good, or shall we choose any other platform?
No, there will be no such limitations as far I know. But if you accommodate all those different components in your circuit in a single editor, then you can design. Otherwise, you can divide module wise. Say
Okay.
one module, under one module you have design one circuit, then connect that circuit, particular circuit in this next module. That you can do.
Okay, sir. Okay. So, sir, thank you a lot. Means once again, I take this opportunity to thank you.
Thank you,
And
Tilak sir, for giving me this opportunity
no,
to present in front of
on
students. And
behalf of the EC department of HIT, we are grateful to you, and I hope that with this talk, the students will be highly benefited, and that is the only target for arranging such webinars and online talks.
yes. Thank you very much. And I will share this PPT with you so that you
Okay.
can share with the students.
Okay, sir. Sure, sir.
Okay.
Sir,
Thank
one
you.
question, sir.
Okay, sir. Yeah.
Sir,
Yes.
one question from students. He has installed PSPICE Schematic Student version 9.1. Is this enough, or I need to download Capture CIS Lite?
No. Any. I have actually mentioned all those options. Okay. They have choose anything as per their requirement, as per their choice. Anything.
Okay, sir. Thank you.
Okay.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir. You can end the session.
So we going to conclude here, Tilak sir.
Yes, sir.
Yes,
So
sir.
we are
So end from your side.
Yes, sir. So thanks again. We are ending the session 3 now, as for today in the first half, and the second half will be the lab as per the schedule by the students and the respective faculty members. So, sir, thank you again, sir. Bhaskar, sir.
Thank you, sir. Thank you.